Hello friends, this is Rakshith. In my last video, I completed the diode circuits and I promised that I will solve gate and IS previous year problems. So in this video and maybe the next video also, I will completely solve the previous year gate and IS problems regarding the diode circuit. So let's start. This is the first question. In this question, he gave a circuit and he is asking us to find the I1 across diode D1 and I2 across diode D2. So friends, in this problem we have more than one diode. So which case should we apply? It comes under case 2. So what is the first step we should do? We should open circuit the diode D1, open circuit the diode D2 and find out the VAC across D1 and VAC across D2. So first step is open circuiting. So I am drawing the equivalent circuit here. After this we should find the VAC across diode D1 and VAC across diode D2. Which diode is having more VAC? It will turn on. So first I am finding across D1, VAC across D1. That is, what is the A voltage? It is connected to ground, so it is 0. Minus, what is C voltage? Since there is no current flowing through this, C is directly connected to minus 10. C voltage is minus 10. That is 10 volt. Next I am calculating across second diode VAC2. A is connected to 10 volt. Minus, C is connected to minus 10. So it is 20 volt. If you observe here, both diode 1 and diode 2 are having VAC voltages greater than threshold voltage. Since it is an ideal diode, threshold voltage is 0. So VAC1 is greater than 0 and VAC2 is greater than 0. Both can turn on. But what's the case? It comes under case 2. The diode which is having more threshold voltage will turn on first. Do you remember that, guys? And after turning that diode on, we should check the conditions for diode again. And if that is also greater than threshold voltage, this will also turn on. So what is the first thing? This diode 2 will turn on. This is the equivalent circuit when the diode 2 is turned on. Now what should we do? We should find VAC across diode D1 again. Here the voltage is 0 volt. Here the voltage is, I am applying nodal analysis here. So V plus 10 by 5k plus V minus 10 by 10k equal to 0. So from this I am getting 2V plus 20 plus V minus 10 equal to 0. From this V is minus 10 by 3. So this voltage is minus 10 by 3. From this I can tell that VAC across diode D1 is 0 minus 10 by 3. That is 3.33, which is greater than 0. This indicates that diode D1 will also turn on because the voltage across diode D1 is greater than threshold voltage. I am explaining the procedure again, friends. See, when there is more than one diode, we should open circuit all diodes and we should find VAC across each diode. The diode which is having more VAC will turn on first. So we should turn on that diode and we should check VAC across another diode again. If this VAC is greater than V threshold, then it will turn on. If it is less than V threshold, it will turn off. It is very simple. You need practice, just practice. So we should turn on this diode also. I am turning it on. If I turn on this diode, what will this voltage will become? It is directly connected to ground. So this voltage will become 0. So this voltage is 0 now. So if this voltage is 0, he is asking us to find the current I1 and current I2. So what is the current I2? 10 minus 0 by 10k. That is 1 milliampere. And what is the current I1? First let me find the current I. I am taking this as I. I is 0 minus of minus 10 by 5k. That is 2 milliampere. I is 2 milliampere. If I apply KCL here, what we will get? I1 plus I2 equal to I. From this, I1 plus I2 is 1 milliampere. I is 2 milliampere. So, I1 equal to 1 milliampere. Is this okay, guys? I am finding the states of the diode and then applying simple network concept. Next question. In the silicon diode circuit shown, find the value of I. So here there are 3 diodes. So what is the first step? Open circuit all the diodes. What is the next step? Calculate the VAC across diodes. I am numbering this as D1, D2, D3. Since there is no current flowing through this voltage is 0. Now VAC across D1 is 3 minus 0, that is 3 volt. VAC across diode 2 is 2 minus 0, that is 2 volt. Similarly, VAC across diode 3 is 1 volt. What I said, diode which is having the more VAC will turn on first. Here which is having the more VAC, diode D1. So this will turn on first. What is the next step? We should calculate the VAC across diode D2 and D3 now. What is the VAC across diode D2? See, since it is turned on, this 3 volt will appear here. That is 2 minus 3 minus 1 volt, which is less than V threshold. So diode D2 will remain in off position. And similarly across diode D1, 1 minus 3, which is minus 2 less than V threshold. Diode D1 also will remain in off position. So there is only voltage 3 volt that will appear here. So what is the current flowing here? I equal to 3 by 1 kilo ohm. That is 3 milliampere. Very simple, guys. But you should know the concept. What is the concept? Open circuit all the diodes, find out the VAC across each diode. The diode which is having the more VAC, turn the diode on first. After turning that diode, check the voltages across first and second again. Sorry, not first and second. We are turning the diode D1 on. After turning this D1 on, check the voltages across D2 and D3 again. And if the voltages are greater than threshold voltage, turn that on. If they are less than threshold voltage, turn the diodes off. In this question, diode 1 is having the more VAC, so I turned this on. And after turning this on, I checked the voltages across 1 and voltages across these two. So here I am getting minus 1 voltage, which is less than V threshold. Here I am getting minus 2 volt, which is less than V threshold. So I open circuited the two diodes because they are in off position only. This 3 volt will come directly here and the current is 3 milliampere. That's it, guys. Next question. Sorry guys, there is a small mistake here. He mentioned it is a silicon diode, but I took this as ideal diode. If this is a silicon diode, when the diode is turned on, what will be the equivalent circuit? There should be 0.7 volt here. So what is the voltage appearing here? 3 minus 0.7 is 2.3 volt. So what is the voltage across D2? 2 minus 2.3. That is minus 0.3, less than with threshold off position. Similarly here also 1 minus 2.3 minus 1.3. So what will be current flowing through this? 2.3 by 1 kilo, that is 2.3 milliampere. These are the small mistakes we will do in the gate exam, guys. So be focused on the question. I'm going to next problem. This is a special question, guys. Why I'm calling it as special means here the diodes are connected in series. So what will you do when the diodes are connected in series? What we will do is generally we'll consider this as single diode, which is having threshold voltage. Suppose this is 1, this is 2. We'll consider this as single diode which is having threshold voltage as V threshold 1 plus V threshold 2. See if there is a silicon diode and a germanium diode connected in series. Silicon voltage threshold voltage is 0.7. Germanium diode threshold voltage is 0.3. So we will consider this as a single diode which is having a threshold voltage of 1 volt. Similarly, if there are two silicon diodes in series, we will consider this as diode which is having threshold voltage of 1.4 volt, 0.7 plus 0.7. If there are two germanium diodes, what we will do? We will consider a single diode which is having threshold voltage of 0.6 volt. So this is the concept, guys. So in the question he mentioned that they are germanium diodes. So what is the equivalent circuit if I consider a single diode? So this is the equivalent circuit. Now what is the next step? We should open circuit the diodes. So I am doing the open circuit equivalent circuit. If you see here, anode to cathode voltage of this diode, I am calling this as 1, this as 2. Anode to cathode voltage of diode 1 is 4 volt, that is 4 minus 0. And anode to cathode voltage of diode 2 is also 4 volt, 4 minus 0. Why it is 0 means 1 kilo is connected to ground, there is no current flowing through 1 kilo. So this 0 volt will directly appear here. So see friends, it is having 4 volt, it is also having 4 volt. So it comes under case 3. When both diodes are having same voltage across that, if VAC is same, then diode which is having less threshold voltage will turn on first. Do you remember this friends? The diode which is having less threshold voltage will turn on first. So in these two diodes which is having less threshold voltage, diode number 2. So I am turning on this diode like this. Since it is a germanium diode, you will get a voltage drop of 0.3 across this. Next, after turning this diode, what we should check? We should check the VAC across diode 1 also. So here voltage is 3.7 volt. So we should check the voltage drop across this VAC. VAC1 will be 4 minus 3.7, that is 0.3 volt. But what is the threshold voltage across the diode? 0.6. Since the voltage is less than threshold voltage, the diode 1 will remain in the off position. It is a tricky question guys, practice well. What I am doing is, I am considering this series as one diode which is having threshold voltage equal to this plus this. Next I am open circuiting this. After open circuiting I am finding the voltage difference VAC. Since VACs are same, diode which is having less V threshold will turn on first. Diode 2 is having the less threshold voltage, so I am turning on that. After turning on, I am getting 3.7 volt here. I am finding the VAC across diode 1 again. If I find VAC across diode 1, I am getting 0.3 volt, but the threshold voltage is 0.6 volt. So diode 1 will remain in the off position. So now what is the current I? I equal to 3.7 by 1 kilo. That is 3.7 milliampere. Is this okay guys? In this question he is telling that it is a silicon diode. The current flowing through diode D1 is I. The current flowing through diode D3 is I dash. If I dash is 30% of I, find the resistance R. So how to solve? Indirectly he is telling that current is flowing, so they are in on state. Since it is a silicon diode, what will be equivalent circuit? So this is the equivalent circuit. Current flowing here is I. Current flowing in this is I dash. So let me apply mesh analysis here. How to apply mesh analysis? Let the current flowing in this be I1, current flowing in this be I2. So I am writing KVL here. What you will get? Minus 10 plus 1.4 plus IR plus 0.7 equal to 0. From this IR equal to 7.7, 13, 11, we will get 7.9 volt. Next, applying here minus 0.7 plus 1 kilo into I2 equal to 0. From this I2 will be 0.7 milliampere. So if I2 is 0.7 milliampere, he given that I dash is 30% of I. What is the I dash? I dash is nothing but I1 minus I2. That is 30% of I1. So 0.7 I1 equal to I2 plus I1 equal to I2 by 0.7. That is 1 milliampere. So I1 is 1 milliampere. Substitute this I1 here. This is nothing but I1. So I1 into R equal to 7.9. R equal to 7.9 by 1 milli. That is 7.9 kilo ohm. This is the solution. Is this okay, guys? This is the last question, friends. He gave a circuit and there are 4 diodes. We are applying a voltage VAB equal to 10 sin omega t here, and he is asking us to find the VXY. He mentioned that these are ideal diodes. So first we will see positive half cycle. Positive half cycle, A will be positive, B will be negative. So what will happen? When it is positive, they both will be in off condition. When this is negative, they both will be in off condition. So circuit will become like this. So there is no current flow because the 4 diodes are in off condition. So in positive cycle, Vxy equal to 0. If you see negative cycle, here negative voltage will be there, here positive voltage will be there. So these 2 diodes will be in on condition. Here it is positive voltage. So these two diodes will also be in on condition. This is the equivalent circuit. On condition, on condition. If you see here, X and Y are short circuited. What is the voltage between X and Y? Again 0. So answer is 0. So these are the GATE and IS previous year problem, friends. If you like my explanation, do like and subscribe to my channel. It motivates me to do more videos. So in the next tutorial, we will start the applications of diode such as rectifiers, clippers and clampers. Don't worry, they are very easy. So we will meet in the next video. Thank you.